Hi, I'm Caroline. This is my presentation for the course CNT 6418 for Computer Forensics 2. My presentation is on Introduction to Linux. I will be talking about some of the basic concepts for Linux. So Linux was actually created by Linus Torvalds in 1991. It's a Unix-like operating system. Now, Linux is designed to be an open source software, so essentially anyone can modify its kernel, which is one of the main advantages. Now, the kernel was originally designed for the x86 architecture, but now it is widely used across all platforms. It's easily portable as well. Some of the most famous examples for Linux is the Android OS and the Chrome OS, which are essentially based out of the Linux kernel. Another great advantage of the Linux is that it's extremely lightweight and efficient. Now these are some of the distributions that I've put together. These are actually just very few popular distributions of Linux. The list is actually pretty endless. Now this essentially stems from the fact that the Linux kernel is actually open source and it can be modified to suit one's needs. And hence there are a number of distributions that are out there. Now, as we know from our previous from our course in CNT 6418, we use Kali Linux and Paladin a lot, which is based out of Linux. Red Hat and SUSE are more of their enterprise level, whereas the remaining are actually open source and they're free. So this is the organization of the operating system, which essentially consists of three parts. We have the kernel, which is the core of the operating system. The kernel controls and manages the hardware, such as the memory, the CPU, disks, external storage, and other hardware. Then we have the shell, which is the interface between the user and the kernel. So a user, such as us, we type in commands into the shell, which is then interpreted and submitted to the kernel for further execution. Now there are a number of shells that are out there, and the bash shell is one of the most common shells used. If you see the picture on the slide, that is the command line, which is essentially the shell. So we type in our commands in here, which is interpreted and sent to the kernel for the execution. Then the third part of the system is the tools and applications, which provide additional functionality to the system. So here I'm going to be talking about file system basics. Now the Linux actually follows a hierarchical file system. Everything in Linux, everything is stored as a file. Everything, including configurations and device settings, everything is stored as a file, which is different from Windows, where everything is such as configuration in Windows is in terms of registry keys. But in Linux, everything is stored as a file, and the files are stored in directories. Now, if you see from the picture on the slide, you can see the top level of the directory tree is the slash, which is the root directory, this is the highest level in the file system level. Now the home directory is for all the user accounts. So each user account has their own home directory. A very important fact of Linux, to me especially, is that Linux is case sensitive. Now these are some of the file systems in Linux. We have the ext2, 3, and 4. Now, ext3 and 4 are one of the most common file systems that are used in Linux distributions nowadays. Then we have the ButterFS or BetterFS. This was actually developed by Oracle, and it actually stands for B-tree file system. This is actually designed for enterprise levels. Then we have another very common file system is XFS, which was developed by Silicon Graphics and is pretty much similar to ext4. And we have the JFS, which is designed by IBM, and the ZFS, which is also designed by Oracle, and it's similar to ButterFS. I've actually provided a reference in my list of references on how we can choose which file system is appropriate for us to use. These are some of the special directories which are pretty important when it comes to the Linux file system. We have the /home, which is, as I had said earlier, it is for user accounts. All the user home directories are stored here. Then the /bin, binaries or executables that are essential to provide functionality to the system are stored here. The /etcs stores more of the system configuration files that control the operating system. /dev holds device files or configuration files of the devices that include all your external storage or your file systems. /proc is it holds special system files that are related to the kernel, such as system memory or hardware configuration. One of the special directories that we should be really careful when it comes to handling. Then we have the /var, which holds files that are usually commonly edited by the system, such as system logging. The /temp, as the name says, is for temporary files. Some programs create log files here and use this directory to temporarily store data. So if we clear the temp folder, we've got to be pretty careful what we clear, since the system might be still using those files. /media contains mount points for removable devices, and /mount is used for mount points for file systems or devices. Mount points here, it's important to know that the mount points here that are created in the /mount are temporary. Now, we have a choice. We can either mount these devices whenever we boot into the system, or if you want these mount points to be automatically mounted when the system is booted, we add these mount points to the /etc/fstab file, which I'll be showing later in the presentation. Now these are the next thing we'll be talking about are the commands. Now commands usually follow a syntax, a usual syntax, that is command followed by an option followed by the arguments. Now to get more information on a command, we can either do command --help or man command. This is actually one of the most important commands you learn in Linux. Now man gives you the manual pages of a command, which essentially gives you all the information that you need to know about a command before you execute it. Now when it comes to the dash, we have two options. For example, from the example that I've shown here, you can either do rm-f, which is remove by force. So when you have a single letter, you use the single dash to precede the single letter, or if you use a word like force, use the dash dash, as I show in the second one where it says rm-force. Now these are some of the basic commands that is pretty important when it comes to working with Linux. As we had learned from the video courses of this course, the ls is to list all the files in the current directory. pwd essentially gives you the present. So the PWD gives you present working directory. That's where you're working from currently. CD changes your current directory to a specified directory. CD dot dot will change your directory to one level above your current directory. Then you have the CP, which is to copy file or directory. The RM will remove a file or an empty directory. Now when it comes to removing directories, we can only remove directories without any force if the directory is empty. However, if the directory has contents, we need to remove the directory by force, that is by providing the option rm-f. The mv is to move or rename a file or directory. Then we have the mk directory, which is to create a directory, or the rm directory, which is to remove an empty directory. Formi gives you the user account that you're logged into currently. Echo is to print the string that you typed in. Now grep is a pretty important command which is used to search for files, for arguments. We can change password with passwd. User add is to create user accounts, and similar to delete user accounts, you can use user delete. Cat, another pretty important command, is to read file contents and display them. Cat has a lot of functionality which we can get more information from its man pages. And shutdown can be used to reboot or turn off a system. Two other really important commands is the chmod and the chown, which is to change the file mode or file owner. I'll be going into detail with these two commands in a couple of slides later. Then we have the diff, which can be used to show the difference between files. Find is used to search for files or directory in a file directory tree. Now find is to search for files, whereas grep is to search for arguments within a file, to search for arguments in its file contents. PS is to list the user's processes in a system. Kill is to terminate a process. And you can use PS to find the list of processes, and using the process ID that you get, you can kill a process. Mount is to mount device or partition, and umount is to unmount device or partition. Now, a pretty important topic when it comes to Linux is permissions. Now, in Linux, each and every file and directory has file permissions, which essentially controls a user account's access to that file or directory. Each file essentially has is of three permission groups: the owner, group, and others. Owner essentially is the owner or the user who created the file or directory. Group is a group of user accounts that can be assigned to a file directory so that they have access to that file or directory. And others are all the other user accounts of the system. Now, each of these permission groups have three types of permission modes. That's the read, the write, and the execute. So read essentially is to be able to read contents of the file directory, write is to be able to write contents to the file or directory, and execute is to be able to execute a file. Now from this snapshot, this is a snapshot I've taken of to demonstrate the permissions of the folders that are there in my working directory. Now we can check out the permissions of the file directory using ls-l. With ls-l, you get the list of directories or files in your working directory in a long format, which essentially gives you the permission groups with their permission modes. So going from the left to the right, we can see the first three The first three stands for user or owner. The second three gives you the group, and the third three gives you the others. For example, we look at the desktop. We can see that the owner or account has read, write, and execute permissions, whereas for group, the group just has read and execute, and others just has read and execute permissions. Now, chmod is essentially can be used to change the permission modes of the permission group, and similarly chown can be used to change the permission groups. Now, I've given a couple of examples on how we can use them to change the permission groups or modes. For example, if you see chmod u plus x will essentially add executable permission to the user, whereas g minus w removes the write permissions from the group, and a plus rwx essentially adds read, write, and execute permissions to all users. So U stands for user, G stands for group, O stands for others, and A stands for all. And similarly, the permission modes are RWX for read, write, and execute. These are some of the text editors that are available on Linux. There are actually quite a few text editors that are there in Linux, and I've listed some of the very common ones that we see nowadays. There's VI, gedit, nano, vim. Usually when it comes to text editor, each person or each user has their own preference. To me, I usually prefer VI or vim. Gedit is pretty easy and pretty useful to first-time users. Now, when it comes to Linux, to me an important concept is able to understand mounting of device or partitions, which is something that we will deal with when we deal with Linux. And when we use the mount command, that essentially creates a mount point in the /mnt folder in our root directory, and when it comes to /mnt, all the mount points created there are just temporary unless we modify the fstab file. So fstab file is essentially a configuration file that automates the mounting process. The /mount holds mount points temporarily, which could be lost after the system reboots, unless it's been listed in the fstab file. Mount points declared in fstab are automatically mounted. So the fstab is essentially a file which can be edited by any of the text editors. So this is how a syntax of an fstab entry looks like. We mentioned the device that we are trying to mount, then the mount point that we're trying to mount to the device to, then the file system of the device, and options, dump, and pass. So the device, so as I mentioned, device is a device or partition to be mounted. Mount point is a directory or on the root file system to access this device or partition. The file system is the file system on the device. Options are mount options, which enable or disable access to the device or partition. Dump is essentially to enable or disable getting backups of the device or partitions. And pass indicates the order in which the device or partition is to be checked for errors during boot time. This is a snapshot of an fstab file. This is a sample. So if you see here, we can see at the bottom of the snapshot the entry for the fstab. So we have the /dev/stb, which is our device, which is the first of the syntax, followed by the mount point to which you want to mount your device to. In this case, it's the /media/disk1, followed by the file system, which is an ext4, and defaults in 0 and 2. So 0 essentially is for to dump, which is to disable getting backups of the device, and 2 stands for pass, which is to indicate the order in which the device is to be checked for errors. So by default, most of the devices should be set to 2 unless it's the root or the boot system device, which needs to be checked, which needs to be placed as 1 in the order. Now default is a set of options. It is usually, or it is mostly stands for these options as I've listed in the slide. Now we can change these options by if for example, if we want to, in this case the default is RW, which is it allows read and write. But if in this case, if you want to make sure that your device cannot be changed, that is, it's read only, we can change the entry for the defaults part as defaults comma RO. So the RO will take precedence over the RW, and will make sure that the device is only read only. This is the /mtab file, which is different from the fstab file. I've shown a snapshot of the mtab file over here. Now the mtab file differs from the fstab. It essentially shows a list of currently mounted drives or partition. This differs from fstab. Now fstab we can edit such that devices or partitions are automatically mounted, whereas mtab gets automatically populated by the mount command, and is really advised not to modify the mtab file, as it's more of a system file. These are the references that I used for my presentation. As I'd mentioned, this is a pretty useful link that I enjoyed on, which explains on how we can select a file system when we work with Linux based on our need. Thank you.